Oh, look at that. It changed my problem on me. So we're going to see y equals 1/2 to the x. And I will say we're all going to get the same graph on this one. So let's go look at it and see what we get. So I had 1/2 to the x. So 1 divided by 2. Close parentheses and raise that to the x. All right, y'all. So let's see what that graph looks like. So notice it does come downhill. It tries to get close to the x-axis over time, but it never crosses that x-axis, okay? So then we want to go pick the picture. And y'all, the only one it can be that looks anything near mine would be this D here. So we're going to click D and hit next. All righty, so we're going to sketch the graph and check it with our graphing calculator if you want to. But before doing that, they want us to describe how it can be obtained from the graph of the basic exponential function. So we just got to figure out what is that +1 doing to this graph. So remember, when you attack that x like that into exponent, if you add, it's going to move it left. If you subtract, it's going to move it right. So we want the one that says we're going to move 1 unit to the left, which will be B. And then down here in the box, you got to put your base. So my base was the 2. Now, we got to click to enlarge the graph. Exponential tool is on the second row, second tool. And then click anywhere on the graph. Now, mine went 1 unit to the left, so I'm going to go to horizontal and move that to -1. And y'all remember the most important thing down here where it says base on the bottom, you got to change that from an E to match the base of your graph. Mine had a base of 2, so I got to put that 2 in there, okay? You got to change that base for sure. And y'all, that's our only move, so we save that. And
okay,
then
where do you do the graph again?
Mm-hmm. All right, so on the second row, you want the little exponential tool that looks like it's going uphill left to right.
Mm-hmm.
Click that and then click it on the graph.
Mm-hmm. Mine did a -5.
Yours did x minus 5.
Yes, sir.
So you'll move right 5.
The horizontal.
Uh-huh.
Okay.
Adding goes left, subtracting goes right.
Okay.
And then whatever your base is in that box, change it from an E to match your base.
Okay.
And then we're just going to save that and be done. All right, then we're going to hit next. So y'all, this one has 2 moves. They're adding 5 to the x, but then at the end, they're subtracting 3. So I'm going to start with the graph. My base is a 2, so I'm going to put my 2 in. Then it says shift it blank 5 units. So remember, since the 5 is being added to the x, that's going to move mine left. So I'm going to come down to here and click left. Now at the end, you got that -3. Subtracting goes down, adding goes up. So since mine was subtracting 3, mine is going to go down 3 units. And then it's going to want me to graph this. So I'm going to click to enlarge my graph. Grab the exponential tool. And then click anywhere in your graph. All right, so the +5 made me go left 5. So I'm going to come over here and go all the way to -5. The -3 is going to make me go vertical down, so that's going to be moved to -3. And then remember, I got to change my base from that E down there to a 2. So this one had 2 moves on it, so then we save that. And then y'all see it's moved the graph for us. So now we just hit next. Hey, y'all, let me write this one down real quick. $68,000 invested at 3.5% interest, compounded quarterly. So A, they want us to find a function for which the amount grows after t years, and then find the amount at t equals 0, 2, 7, and 10 years. All right, y'all, so I'm gonna do that on my paper, and then we'll come back and put that in. All righty, so remember, we're using the formulas, A of t equals my principal times 1 plus r divided by n, all raised to the nt. So for A, they want us to figure out this formula here. So P is my principal, that's $68,000. Parentheses, 1 plus R. R is our interest rate. So mine's 3.5%, so that's going to be 3.5%. But we got to turn that 3.5% into a decimal. So we're going to move this decimal left twice. And y'all, that means I got to add a 0. So I'm going to get a 0.035. So I'm going to put that in for the R, 0.035. N is the number of compounds. This is quarterly. So quarterly means it's going to be 4 times a year. So we put our 4 there. And then the 4 goes for the N. And then T is our time.
So
Now,
if it's 4 halves, the percentage, if mine say 4 halves, what would that be? Would it be 0.435?
so it was like this 4.5.
Yes.
So that'd be 0.045.
Okay.
Now, y'all, what MathLab wants us to do before we put it into the computer is figure out what our 1 plus 0.035 divided by 4 is so that we can put that in here. So I'm going to go to my calculator real quick. I'm going to quit this screen. And I'm just going to see what that equals. 1 plus 0.035 divided by 4. So I get a 1.00875.
Hold on. 1 plus.
Now, if you had the point, what you had, 0.045 divided by 4, you'd get a 1.01125. As long as yours was is yours quarterly?
Yes.
Yeah, so that's what yours is going to have in there, okay?
Okay.
All right, y'all, so I replaced that with what I just got. So this is now what I'm going to put into MathLab. So let me go back to MathLab real quick. So A of T is going to equal 68,000 parentheses 1.00875 close parentheses and then my exponent will be 4t. Alrighty, now it wants me to figure out the amount of money in that account at 0 years, 2 years, 7, and 10. I'm going to graph this because it's the quickest way to do these is by using your y equals and then that table. So I'm going to go to my calculator. I'm going to go to y equals. And I'm going to put in my 68,000. Parentheses 1.00875 close parentheses, and then I'm going to do my exponent is going to be 4. On the calculator, you got to use the x's. Okay, don't put a t there. Put your x on that calculator. Now, I'm going to hit second graph to pull up my table. So let me arrow up one because I had to start at 0. So y'all notice at 0, we got 68,000. Which that makes sense. If you started with 68,000, no time has passed, you got to have 68,000 in there. At 2, I had 72,908. Next, I had to figure out 7. So let me arrow down to 7. At 7, I had 86,786. And then it wanted me to go to 10. So 8, 9, and 10. At 10, I have 96,350. I've got
Okay,
my
when we put the equation in for the y equals the first one, and then do I press graph?
no, hit second graph.
Okay, put second graph.
Uh-huh.
Okay.
And
okay,
it'll pull up that table.
Okay.
What if your graph is in like decimals?
Oh, so let me see. So on your table, you're getting decimals.
Yeah, like it doesn't even give a 0.
All right, so here's what
I
I
just do them on paper normally, so
yeah,
I
well,
don't know.
y'all are still okay. So hit second table set. So let's start our table at 0. And then arrow down to where that triangle table is and put that at 1. Because it sounds like yours is still doing halves and cube thirds and stuff. So start your table at 0. Delta table, which is a triangle, put that at 1, and then go to second graph. So
Okay,
whoever was asking me that, did that fix you?
Okay, can you do that one more time? Because mine's doing the same thing.
All right,
Yeah, I don't know what you just did.
second window to do the table set. Are y'all pulling this up like mine looks right now?
Yeah.
Mine just say XM.
Just second in window.
Second is the blue button, and then hit the window button.
Okay. Yes, it's doing it.
Make sure that table start is 0. And then arrow down, and triangle table needs to be set at 1.
Okay, mine fixed. Thank you.
Uh-huh. Now hit the blue button and the graph button to pull up your table.
Mine's still doing the same thing.
If it, I don't know, then that's the only way that I know to set the actual table. So
Yeah, mine's
yeah, we'll have to mess with that after class. And then
Okay.
I'll try to figure it out. All right, y'all, 68,000 here. At 2 years, you get 72,908. 7 years, 786. And then at 10 years, I had 96,350. Now, y'all, I will say this. If you're weak at graphing, put this formula into your, just use the front of the calculator. And for each number, like I'm going to start out with 0. Do this 4 times individually on your calculator. So you can do this. Go to your calculator. And just punch them in individually. 68,000. Parentheses. 1.00875. Close parentheses. Do your exponent. And my first one was 4 times 0. And then when you hit enter doing that, you'll get the same answers, but you just got to do it 4 different times. So that'd be another way to do that one, okay? All right, y'all. So next, I think it's the little girl with the birthday. So let's see, Melissa's 6th birthday. She gets $5,000 CD, 6% interest, compounded quarterly. If it matures on her 10th birthday, how much money will be available? And then notice this one, we got around to the nearest cents. So that means 2 decimal places on this one. Now, what's nice is it's the same exact formula. I'm still going to be doing my A of T equals P times 1 plus R over N raised to the N times T. We know our principal, that's her 5,000 she started with. 1 plus interest rate, 6%. Move that decimal left twice, which means I have to add a 0 so that I get a 0.06. N for me is quarterly again, so that's going to be 4. And then NT would be 4 times. So T we got to figure out. She got it on her 6th birthday. It matured on her 10th birthday. So we would do 10 minus 6. And that'll give me 4 years. So that'll be 4 times 4 for my exponent. So y'all, we're going to go punch this in and round it 2 decimal places, okay?
If it's semi-annually, is that 2?
Uh-huh. Yeah, I've seen them use quarterly on this one and semi-annually mostly.
So that's where you get the 4 from?
The 4 I got from the quarterly. What does yours say?
Mine say semi.
That'd be 2 for you.
Okay.
Okay. All right, y'all. Then I'm just gonna punch that in. 5,000. 1 plus 0.06 divided by my 4. And then my exponent was 4 times 4. All right, so let's hit enter and we're going to round this 2 decimal places. So mine looks like $6,344. And let's see, 9, 2, the 2 has a 7 behind it. So I'm gonna round that up to a 9.3. So then I would put that in, let's see. So 6344.93. Now listen on this, y'all. You got to get a number bigger than 5,000 if that's what you're starting with, okay? Because remember, this is a interest type problem, so the money's got to get bigger instead of smaller. All right, so we would hit next.
Oh, fucking no.
What? I didn't hear that. I thought I didn't hear it though. All right, y'all. Log base 10 of 0.1. All these we can knock out on the calculator. So remember, if it's got a base, you can hit the math, arrow down to log base. Hit enter, put in your base of 10. Arrow right, and then mine had what, 0.1? So log base 10 of 0.1, once I hit enter. Now remember, this is a decimal, so I should get a negative answer.
-2.
It depends on what you started with. What was your log base 10 of?
0.01.
So that'd be right for yours. All right, so see, mine just had a 0.1, so mine was actually a -1. 0.01 would be -2, 0.001 would be a -3, and so on. All right, log base 8 of 8 to the third. I'm going to do that on the calculator, same thing. So I'm going to go to math and get that log base again. Hit enter. So it's a log base 8, and then I'm going to arrow right, and it was 8 to the third, so that'll be a 8 exponent 3. So y'all should match the base and the result base. Only thing going to differ is our numbers on this. But notice, if the base of the log matches the base of the result, the answer will always be whatever y'all's exponent was. So mine had exponent 3, so that would be my answer. So I'm just going to come in here and put my 3. All right, y'all. Log base 125 of 5. Back to the calculator. I'm going to hit math and go to log base again. Enter. And that was 125 and 5. So put in your base, put in that result, hit enter. Now, if you get a decimal, you got to turn that back into a fraction. So hit math and enter. That'll turn it into a fraction for MATLAB. So I get a 1/3 on that. So let me go put that in. So y'all getting that one?
I'm not getting a fraction when I hit the fraction.
What's your decimal? Point what?
I think it was like 34.3479.
So you got to hit the math button and enter it twice.
I did.
So
And I
hey,
still got the decimal.
actually, what was your actual problem? Log what of what?
The log 125 of 5.
Okay, so let me go punch that in. I'm gonna put my 125 here. Arrow right and put in my 5. Now enter. So you're getting a 0.33333. So what we got to do is hit math button again.
Okay.
And then hit enter twice.
Got it.
Okay.
I got it.
So you're getting oh, you had the almost same problem as me then.
Yes.
Uh-huh. All right, y'all. So we can use the calculator, but this one, a log base 15 of 1. I don't care what base you have. If that result is a 1, there's only one exponent that can turn a number into a 1. Do y'all remember?
0.
It is definitely 0. But y'all, we can push it in just to verify. So go to math and down to log base. And I had a 15 for my base. And y'all, like I said, it don't matter what base you got. If you got a 1 sitting there in that result, you're going to get a big fat 0 on that, okay? So y'all listen, you can't miss number 9 because every number 9 is going to be 0 on the test and in the review every time, okay? All right, so let me start writing these down because now we actually got to do some work. Convert to a log equation. They're giving me 10 to the 5th equals 100,000. All right, so 10 to the 5th equals 100,000. They want me to convert it to a log. So you got to write log. The base of the log is the same thing as the base for the exponential. So your base will be a 10. Your result will be whatever's on the right side of the equals. Mine is 100,000. That's going to equal the exponent, which is the 5. So the only thing different for us will be the 5 and whatever amount of money they give you here. All right, so I'm gonna go put that into Math Lab. So log LOG base, you got to come down here and get the little box with the blue box to the bottom right that says subscript. Put in your 10. Arrow right. Put in your 100,000. And then put in your equals. And then your 5. Or whatever y'all's exponent was, okay?
Okay, can I see how you put it in the calculator?
Do it now?
Can I see how you put it in the calculator?
Oh, I didn't put this one in the calculator. This one I just wrote out. All they want me to do is convert it. They don't want me to use the calculator. So you
Okay,
got
so if mine's 10 to the 2nd equals 100, will mine be 2?
so yours will be like this: log 10 of 100 equals 2. But you got to put that whole thing in.
So if we have 100,000 like you do, we put a comma in Math Lab? Because
I
I do sometimes and don't sometimes. I don't know if it matters on the reviews.
no, I don't use a comma.
Okay.
It shouldn't mark it wrong if you did use a comma. I just punch ever how many zeros and go.
Mr. Eugene, if
Uh-huh.
it so happens to mark it incorrectly, would you so happen to fix it, or would that be just like a thing that would be sorted out with math labs?
So what was the question?
So, sir, I was asking that if it does count it, would you be able to correct it for us? by
Oh,
any
if you
chance?
put a comma in that
Yeah, like
and
if
it
say we
counted
do.
it wrong, yeah, I can override them.
Oh, okay.
So yeah, if it did do that, which it shouldn't, but if it did, let me know and I can fix that. All right, y'all, let me write this one down. E to the negative 5 equals T. All right, so E to the negative 5 equals T. I'm going to write it as a log again. So I'm going to come down with my log. My base is the E. My result is the T. And that's going to equal your negative 5. Now, since this is a log base E, we're going to write that as a ln of T equals negative 5. Y'all's, the only thing that should be different on y'all's is that exponent. Everybody should have an E and a T. The only difference will be the negative 5 on us, okay? Now,
So we put it in the math lab is like LN.
ln, So when we go to math lab, now, if you use an IN, it won't make it bright and darken it. You got to use an LN. See how it makes it real bold? And then
Yeah.
I'll do my T, and that's going to equal when I get a negative 5. So I'm pretty sure y'all's will be ln of T equals negative whatever number they gave y'all.
So if ours was a positive 3, it'll be a positive 3.
Yours had E to the 3 equals T.
Yeah.
So yours will be ln of T equals 3.
Okay.
All right, y'all. So let me turn my page. This one's going the other way. So let me write this down. Log 3 of 9 equals 2. And what they want us to do is write these as exponential. So for each exponential, you take the base of the log, which is the 3. Raise it to the exponent, which is the 2. That's going to equal your result, which is the 9. So remember, base of the log raised to the exponent equals that result you get in the middle. So we have to write this whole thing in there now. So we're going to get in the box. So I had 3, and then come down here and grab the exponent box. Squared, arrow right. Make sure you arrow right down from that exponent and then put your equals 9. All right, y'all, then we're going to hit next. All right, so notice same thing, but now they're just using log A of a capital T equals a negative Z. So since this T is capitalized, when I write this answer in, that T has to be capitalized, okay? So let me work this one. And you'll notice this one I'm going to work the same way I did this. The A is in place of where the 3 was. So A is my base. Negative Z is in place of the 2. So negative Z is your exponent. That's going to equal the result of the T. So these two problems worked exactly the same way. So y'all got to make sure I capitalize that T when I put this in Math Lab. So let's go. So I had my A exponent negative Z, arrow right off that exponent. and put your equals, and then mine was a capital T. Okay, so MathLab is really picky on capital letters or not, okay? All right, y'all. So now this one, LN 592.7. They want me to use a calculator and round this 4 decimal places, okay? So let's go to our calculator. All right, rounding it 4 decimal places. LN is on the very front of my calculator, about a 4. So I'm going to hit the LN, and then I'm going to punch in my 592.7. Now I'm going to hit enter. So y'all, we got around this 4 decimal places. So let's see, 6.384. So the 4th spot is the 6, but behind the 6 is an 8. So I got to round that 6 up into a 7. So I'm going to get a 6.3847 on mine, okay? All righty, so we had a 6.3847. Okay, so just remember, if you're rounding 4 decimal places, you look at the 5th decimal place to determine on whether you're moving it up or down or leaving it the same. All right, so it says use change of base. Well, y'all, this is modern time, so I'm just going to go to my calculator and go to the log base. Notice, round this one 4 decimal places also. So I'm going to go to my calculator. Whoops, let me get my problem. I didn't write it down real quick. So I got a log base 3 of a 10. So I'm going to hit my log, go to math, arrow down to log base. Hit enter. My base was a 3. Arrow right. My result was a 10. And hit enter. All right, so let's see. 2.095. My 4th number is a 9. And you always got a 0 after it. So mine's going to stay a 9. So mine's going to be 2.0959. So 2.0959. So are y'all decent on that rounding?
Yes.
Not too fond of it on my own.
So mine's 2.9534. So I put in the MathLab 2.9534.
Okay, so what was your let me go to math. and
Mine
then-
was the base was 4
uh-huh.
and 60.
4 and 60.
Mm-hmm.
All right, so let's see what that'll give us. So I would do 2.9534. Since you had a 4 after that 4, it's going to stay the same.
Okay.
So 2.9534. I think that's what you said, right?
Yeah.
Okay. All right, now these want me to express as a sum of logarithms. So I got a log base 4 of 4 times 64. So let me work this out real quick, y'all, and then we'll come put that in. So remember, sum means they're going to be added when you're done. So basically, you distribute the log 4 to both of these and write it as addition. So you're going to get a log base 4 of 4 plus distributing the log 4 to the second factor gives me a log base 4 of 64. Now, we don't have to simplify this any further. They just wanted me to write it as a sum. So now, you gotta use the log, L-O-G, use the subscript with the box to the bottom right, and put in your 4, arrow out of that to the right, and put in the 4. Then I had a plus, write log again, grab that subscript, put in that 4, arrow right, and then put in your 64. So you got to have a log base, whatever, plus a log base, whatever, okay? Now, y'all, this is my favorite one here. When it says express it as a product, I got a log base b of t to the 7. What's the one move I got to do to that?
Move it to the front of log.
Move the 7 to the front of the log. So whatever your exponent is, you're going to come up here and write the exponent first. So for me, mine was an exponent of 7. So I'm going to write my 7 and then my log. Come down here and hit my subscript for my base of a B. Ooh, that looks like a capital B. So I'm going to make that a capital B. Arrow right and put in my little t. So all you're doing on that when it says express it as a product, you're bringing the exponent down to the front and then writing the rest of it, okay? They know they're about to get trickier here. Let's see. All righty, y'all. So this one I'll actually will write down. So this is what, number 18? So they got a log base D of x to the 6, y to the 4th, and a z. So y'all, I can pretty much, the only difference is going to be maybe the base might not be a D for y'all, and your exponents might not be a 6 and a 4 for the x and y. Other than that, everything else will be the same.
What if it doesn't give you a base? We just don't put one in.
Also, here's just a log and then x6, y, whatever, z.
Yeah, mine is. Well, it's probably because mine isn't log. It's the ln x7y4z.
Okay, so I'll look at both of those.
Miss Eugene, I also have a quick question. Would some of these, would you need to round on any of them?
So again now?
I said for some of these, would you need to round?
Not
for
on
some
this
of
problem,
them.
there ain't nothing round. The only ones they'll say round it in the answer box, they'll tell you to round them off or whatever.
Okay, the reason why I asked is because for some of the homework with it, I got some of them wrong because I didn't round it, at least like to the 1 up. So that's why I was asking.
Yeah, some of them, if it comes out as a decimal, those answers, they usually won't round it out, okay?
Yes, sir.
And most of them in this section have been rounding them out like 4 decimal places. So y'all, let's look at these. So mine did have a base, and it wanted me to rewrite it as sums or differences. Well, since mine are all being multiplied just like y'all's will be, this would be rewritten as sums. So we distribute the log D to all 3 factors. So you're going to get a log base D of x to the 6 plus my log base D of y to the fourth plus my log base D of a z. Now, at this point, you got to invoke the power rule, which means you got to bring any exponents down to the front of those logs. So I'm going to end up with a 6 log D of x plus this one would give me a 4 log D of y. And then this one stays the same, log D of z. So that's what I'm going to put in for mine. Now, if you did have an ln, you would get an ln of x to the 7th plus a ln of y to the 4th plus a ln of z. And guess what? You're going to have to then bring your exponents to the front of the ln. So you get a 7 ln x plus 4 ln y, and then plus your ln of z. So notice they're both similar. And if you didn't have a d here, you would just have a log x6, log y4, log z, and then bring them down just like the ln, okay? So it looks like the only thing they're changing up mainly are our exponents, and then either hitting us with a log or a ln. Well, now this one takes time to put in because I had a 6 log. Mine had a base D, arrow right, put in my x. Then it was a plus 4 log base D, arrow right, and put in my y. Then I had a plus log, put in my base of D, arrow right, and put in my z. So you had 3 factors in there. You got to have 3 logs on that, okay? All righty. 19, this is the big one. That's why I told y'all to put a star by this one in your homework. Log base B of a p squared q5 over m5 b8. All righty, y'all. So here we go. So if you're doing these online with me, are y'all using logs like mine?
Yes.
Okay. Is your base a B like mine?
Yes, the only number that's different for me is the m, and mine's a 4 instead of a 5.
Okay. So I was thinking these ones were really, really pretty close. So what we got to do on this, anything on top, we rewrite it added. Anything from the bottom, we subtract. And we're going to distribute our log B to all 4 factors. So y'all, we should get a log B of p squared plus a log base B of q to the 5th. So both factors on top are positive. Now we subtract the factors on bottom. So I got to subtract a log B of m5. I got to subtract my log B of b to the 8th. And guess what? My last step is to, at least on 3 of these, we're going to bring our exponents down to the front. But y'all, this last one, log base B of b to the 8th. What's that equal in the long run?
One.
Well, the log B of b part equals 1. So that basically,
Just leave your 8.
Just do the 8, yeah.
because 8 times 1 is just 8. There you go. So what we'll do, we'll move the exponents on the first three up, and then that's just going to be a -8 at the end, okay? So I'm going to have a 2 log b of p plus my 5 log b of q minus 5 log b of m minus my 8. So y'all should be pretty close. The only differences might be the exponents, like you said, the 2 to 5 or that 5. And then y'all's number might not be an 8. Y'all might have had a B7, a B4, or whatever. Ooh, y'all, that's a long one to put in there, ain't it? Oh, look, I don't even have to put it in. We just got to find an answer that matches us. So it cannot be A and B because they didn't do nothing with that log B of A, log B of B stuff. So let's see which one matches us. And it can't be C because they got the numbers in the wrong spot, don't they? That 2 should have been in front of the log, not by the P. So y'all, there's only one answer I can pick. So for me, it's got to be D. Make sure your exponents are in front of the log. The first 2 got to be added and then minus the last 2. And the very last one has to be just the number for y'all, okay? So yeah, they do some wild stuff to some of them above, okay. All righty, y'all. ln of x squared plus 10x plus 16 minus ln x plus 8. Ours will be really similar, other than y'all's polynomials might be a little different.
Is C? I mean B.
Oh man, that was quick. Let's see.
I already did it. Sorry.
And I'll tell you, if you do this enough, you can notice how quick you'll get them answers. All right, so for me, I've got to put my x squared plus 10x plus 16 on top. Remember, this is being subtracted, so the x plus 8 goes to the bottom. So on our number 20, we got to factor the top and put that over that x plus 8. Because there's nothing I can do to the x plus 8. So let's factor this top. X squared is an x and an x. 16 is positive, so both factors have the same sign as the 10 in the middle. I need factors of 16 that add to get 10. And one of them better be an 8. So let's see, 16 could be 1 and 16, 2 and 8, and 4 and 4. So y'all, the ones I need are going to be the 2 and the 8. That way you can come in and cancel the x plus 8s. And I end it up with my ln of x plus 2. I think you was right on that, wasn't you?
Yes.
And I'm pretty sure on all of y'all's number 20, it's going to have an answer similar to this. Okay. I don't even know how they got this last answer. D. A, I think they multiplied all that stuff together. And y'all, A, they didn't even simplify it. They just rewrote it as a single fraction. So, yeah, definitely on that would be B. All right, what is this? 21 says solve for x. 6 to the 7x equals 36. So do y'all have any of them that are y'all's different? All righty. So on 21, whatever number's on this side, your 21 will rewrite on the right side. So I'm going to rewrite my 36. Y'all, let's think about it. How many times you got to multiply 6 times itself to get me a 36?
6.
Well, it'll be 6
Right.
times 6, but how many times did you do that?
Twice.
Twice. There you
Oh,
go.
yeah, right.
So rewrite 36 as 6 squared. So then replace it with 6 squared here. So you get 6 to the 7x equals 6 squared. So y'all notice the 6's match. So since these bases match, that means the exponents have to be equal. So I'm going to have my 7x equal to 2. So are y'all working on one you need help with?
I had got a fraction
For your
on
answer?
mine. Yeah, mine's 4 to the 3rd to the x equals 256.
4 to the
3rd x
uh-huh.
equals 256.
Okay, because watch this. When I divide both sides by 7 on mine, guess what? I get a fraction.
Okay.
So let's see. 256, I would have rewrote as, what's that? 4 to the 4th power. So you would have had 4 to the 3x equals 4 to the 4th. Your base is matched. So 3x equals 4. Divide that by 3. So you should have got a 4/3.
Okay.
All right, so mine was a 2/7. So let me go put that in. Now, y'all, 22, unfortunately, we can't rewrite them with the same base, but I got a 3 to the x equals 8. Now, this one, look at this answer blank. It says round to 4 decimal places as needed. That's pretty much telling me I'm probably going to get decimals on this, okay? So, y'all, since I can't rewrite 8 using a 3, because 3's go from 3 to 9, 27, and so on. So we got to take a log of both sides. So the log of 3 to the x will equal log of 8. And the reason we done that, because now we can bring our x down to the front. And we get an x log 3 equals log 8. So y'all to finish this, I'm going to divide both sides by the log 3. So that'll equal log 8 divided by log 3. So notice this side that cancels. I'm left with my x. Now, when I punch this in, I'm going to put my 8 in closed parentheses. And then on my bottom log. So notice, it's always the log of this side divided by the log of this base. Every one of ours will be similar.
I have a question.
Uh-huh.
What if you put LM for the log? Will it count it wrong?
Oh, so let me show you something. Let me go to my calculator. So watch this. If I do a log, mine was log 8 on top, close parentheses, and then I'm going to divide by log 3 on the bottom, close parentheses. Watch what I get. Now, if I do a ln of 8 on the top, divided by a ln of 3 on the bottom, watch what I get. I get the same exact answer. Now, what you can't do is do a log on one number and an ln on the other. But as long as they're either both logs or both ln's, it'll work out either way, okay?
Okay, thank you.
All right,
So,
y'all.
so we're on question 22, right?
Yeah,
So I could have did a decimal, right?
you got to get a decimal on that. Uh-huh.
Okay.
So I'm showing 1.89278. My fourth digit for decimals is a 7, but y'all got an 8 behind it. So I'm going to turn my 7 into an 8. So I'm gonna get a 1.8928 for mine. So yeah, and I'll tell you, you see where it says round to 4 decimal places as needed. When you see that under your answer, that almost guarantees you're getting a decimal, okay? All right, 1.8928. All righty, y'all. Let's see what we got next. So now we get into the equation. So this is 23. So I got a log base 5. 4x minus 6 equals 3. So y'all's will be similar. You might not have the same base and numbers as me, but it will be similar to that. So to solve this one, you're going to rewrite it as exponential. So the base will be the 5. Your exponent will be whatever's on the right side of the equals. So mine's a 3. That's going to equal this result inside the parentheses of a 4x minus 6. So y'all's should be similar, but different numbers probably. So first I got to figure out what is 5 times 5 times 5. So that's going to give me 125 equals 4x minus 6. And y'all, at this point, it's just a matter of solving this. So to solve mine, I would add 6 to both sides. So that's going to give me 131 equal to my 4x. And then to make that a 1x, I divide both sides by the 4. So those cancel, and that's my x. Y'all, I don't think mine will simplify, so I'm going to leave that at 131 over 4. So let's go put that in. So what I get, 131 divided by 4. So are y'all good on that one?
Yes.
All righty, y'all. So let's see, we got next. All righty, log base 4 of t plus 14 minus a log base 4 of t plus 6 equals a log base 4 of a t. So we'll be similar, but I'm sure the numbers are going to be off. So first thing you got to do is combine your logs on the left side. Since they're being subtracted, it's going to look like a quotient or division. So bring out the log 4. Positive stuff, t plus 14 goes to the top. Stuff being subtracted, the t plus 6 goes to the bottom. And y'all, that's going to equal the right side, which is a log base 4 of a t. So anytime you got 2 log on one on each side like this, log 4 of this equals a log 4 of the t. Since these log bases match, so the log bases match, since the log bases match, that means that the t plus 14 over t plus 6 equals that t. So every one of us will have some kind of fraction equal to whatever our variable was. So y'all, this is where I taught us, put a 1 under that t and cross multiply this stuff. So this t plus 14 multiplies by the 1. So that's basically 1 times t plus 14. That's going to equal this t plus 6 times that t. So you get a t times t plus 6. All right, so what we want to do now, get rid of parentheses. 1 times t is t. 1 times 14 is 14. Now the right side, t times t is t squared plus t times 6 is a 6t. So since I got this t squared, I need to move all these over to this side. So y'all, I'm going to subtract a t from both sides. And I'm going to subtract a 14 from both sides. That way on this side now is a big 0. I'm going to bring down my t squared. 6t minus the 1t left me 5t. And then bring down my 14. So at this point, you got to factor this. So the t squared is a t and a t. This 14 is negative. That means you're going to have unlike signs. Everybody will have unlike signs on this part. Now, I need factors of this 14 here. That'll give me a 5. So let's see, 14 is 1 and 14, 2 and 7. So I need 2 and 7 because 7 minus 2 will give me that 5. So y'all, let me ask you this. I got a 2 and a 7. Which one am I going to make positive?
7.
Good job. 7 will be positive because the middle number was positive. All right, y'all. So at this point, we have to set both of those factors equal to 0 and solve for the t. So y'all, the first one, I'm just going to subtract 7. And I get t as a negative 7. The second one, I'm going to add 2. And I get t is a positive 2. So for 24, what are we putting in that answer blank?
The one.
Oh, I think I heard it, but I couldn't. It broke up.
The positive one.
The positive one. You're going to cancel out that negative one every single time. All right, y'all. So let me go do what y'all said and put in my positive 2. So I put in my 2, and then we hit next. All right, y'all, guess what? Last one. And this is similar to what we just did, but it don't have that log on the right side. So let's see what I got here. I got a log. I got a log base 2 of x plus 3 plus a log base 2 of x minus 3 equals 4. So on this one, we first got to start out combining our logs on the left side. Since they're being added, it'll look like a product. So bring out your log base 2. So we'll have our x plus 3 times our x minus 3. All of that will equal 4. And y'all, at this point, I'm going to rewrite it as exponential. So your base is the 2. Your exponent is the 4. And that's going to equal this product I got here, x plus 3 times my x minus 3. So y'all should be really close. The only differences will be the log 2 stuff. And you might have 5 and 5, 7 and 7. But these will match with the numbers, although one will be added, one will be subtracted. And then y'all might not have a 4 here. So 2 to the 4, 2 times 2 is 4, times 2 is 8, times 2 is 16. So I'm going to have 16 there. Now, notice, these are conjugate pairs. Conjugate
Can we
pairs.
FOIL those instead
Well,
of regular?
Since these are conjugate pairs, I'm not going to FOIL it out the long way, remember. I'm going to shortcut FOIL this. Because anytime you got these conjugate pairs where they match up everything except for one's being added, one's being subtracted, all we got to do is this. X times X and get our X squared. And then the 3 times -3 will be -9. So if you got an X plus 5, X minus 5, you're going to get an X squared minus 25. Any of y'all got different numbers than me?
Yes,
So what are your two numbers?
8.
So you'll have an X squared minus 64 at this point.
Okay.
Yeah. And we don't waste our time pulling it all the way out because this 3x in the center and this -3x on the outside, those are going to cancel every time. Now, here's what's nice on this one. I'm going to add 9 to both sides so that I get a 25 over here equals my X squared. So who had the 8s?
Me,
What was on your left side?
plus 8.
No, I mean, not the stuff you're pulling on the other side. Like I had 2 to the 4th. What'd you have over here?
I haven't even did it out, the whole thing out.
So what's your log base?
6.
So you had a 6 there. And what was
Mhm.
your right side?
2.
So you had something like that.
Mm-hmm.
So at this point, yours will be 36 equals X squared minus 64. And you would add 64 to both sides. So you're going to get 100 equals your X squared.
So that's the answer.
Well, on
You have to
mine,
square it.
I got to do the square roots. There you go. So square root of 25.
5.
And y'all, on this one, I don't even care about the -5 because I can't keep a negative answer for these logs. So I'm only looking for one square root, which is a 5 for me. And whoever over here, what was your answer? Square root of 100 was
10.
10. There you go.
So it's 10 equals X.
And now watch when I put mine in. We don't even need to put the equals. You see, they have already got the X equals. So for me, I'm just putting a 5, and you're just putting a 10 on yours. Now, if y'all accidentally put a X equals on that, but you had your 5, I can override that also. All right, y'all, let's see what's next. Oh, hold
Nothing.
on, that's the last one.
I need help with the FRUO, so
All right, so we did good on that one. So let me go back to. All right, what number?
I need help with number. I gotta go up.
If we got them all right, do we need to stay?
Oh no, if you're good, that's all I'm doing is reviewing that today. So if you're good on that, I'm gonna quit my recording and I'll see.